So parallel lines mean that these lines will never intersect. And today we're going to talk about why they never intersect. You have two L's right here. The symbol for parallel is actually just two lines right next to each other. Versus the opposite of that is going to be perpendicular. And perpendicular lines, they intersect at a 90-degree angle, right? So they make a plus sign. And the symbol for perpendicular is going to be an upside down T, because you can see that that would make 90 degrees. So we're going to look and investigate parallel lines by graphing these two equations. So I'm going to graph this first one in red. I'll graph the second one in blue. We have graphed a lot of y equals mx plus b. Where do we start to graph 2x plus 1? Where do we start? At the plus 1. And then what does this 2 represent? This is my slope. So we're going to rise 2 and run 1. And you can do that a couple of times if you need more than one dot. And we're going to draw our line. For this second equation, I'm going to use blue. Where do we start to graph this second equation? The -4, and remember that's our y-intercept, so we're on our y-axis, and our slope is also rise 2, run 1. And we can draw our line. So what do you notice about our lines? They are in fact parallel. They're never going to intersect. Why are they never going to intersect? They are at the same angle, which is called the, what is this one right here? The same slope. So because they have the same slope, they will never intersect because they are rising and running the same amount each time. Okay, so our rule for parallel lines is going to be parallel lines have the same, that's the key, the same slope. The y-intercept does not matter. If they have the same slope, they are never going to intersect and they will be parallel. So we're going to do the same thing. We're going to graph these two equations for perpendicular. So where do I start to graph 1/3 x minus 2? We're going to start down here. Y-intercept is -2. And what is my rise over run on this one? Rise 1, run 3. And again, you can do that a couple of times if you need to have a couple dots. There's our line. What about if we're going to graph -3x plus 2? Where are we going to start there? 2, right? And our slope is rise over run. So it's negative. We're going to go down. 1, 2, 3 over 1. 1, 2, 3 over 1. And that's all information that we've done before. The only new part is we're going to see how it makes parallel and perpendicular. So we're going to compare the slopes just like we did in parallel, right? Parallel, they had the same slope. So in perpendicular, we had a slope of 1/3 and we have a slope of -3 over 1. What is the first thing you notice about these two slopes? One is positive and one is negative, which makes sense because if they're going to intersect, one has to be going up and one is going to be going down. So let's start with that. So we can say, I'm going to use the symbol for perpendicular just because it's a very long word. So perpendicular lines have, so if one is positive and one is negative, they have opposite signs. Anything else you notice about, there's an and on this one. It has to meet both criteria. And they are flipped. Or we can, let's not use they, let's say the slope is flipped. Also known as the reciprocal. If you think way back to 6th grade math, flipped. Reciprocal, refliprocal, reciprocal. So if you look, what happened to our slope, right? It was 1/3, and then we made the numerator the denominator and vice versa, and we flipped it. So we have to change the sign. If it's a positive, it'll become a negative. If it's a negative, it'll become a positive. And we need to take that slope and flip it. So here it says we're going to write an equation. We're just going to stick with slope-intercept today, y equals mx plus b, that passes through 1, -4, and it is parallel. Okay, first of all, parallel means what? What did we just say? Does your slope stay the same or different? Okay, so same slope. What is my slope in y equals -3x plus 5? What is my slope here? Just -3 for m, right? We aren't worried about the b. So we need to write an equation with a slope of -3 and an x and a y of 1 and -4. Since we have a point and a slope, we are going to start with y minus y1 equals mx minus x1, okay, where we're filling in these spaces. And what do we have to remember to do when we put those coordinates into there? We have to flip those signs, okay? So let's start with y minus, what are we going to put there? What is my y1? -4, and if we're going to put it in, it becomes a positive. Good. Equals, what was my slope? -3, that's going to stay. X minus, what's my x1? It's going to be just -1. Do we know how to change this to y equals mx plus b? Yes. How do we change this? We're going to distribute y plus 4. So this is taking something that we've done before, and the only new thing is that we need to make sure we're keeping the same slope. A negative times a negative is a +3, and then what do I do with that 4? Nope. We're going to subtract it. So y equals -3x minus 1. And we could graph this in Desmos or on our calculator, and we could graph this one and in fact make sure that it is parallel. So on the graph is a little bit easier. They're giving you, it does say parallel. What do we know about parallel? Same slope, all right? So we can even make a little note, same slope. So that means we have to actually find the slope on this graph, yes? How do we find slope on a graph? Rise over run. So just pick a point. So I'm going to rise 1 and run how many? 2. So I know my slope. I'm just going to write it over here. My slope is 1 over 2. Excuse me. Rise over run. And then we have a 0.46. Can I just graph that on my... Can I do this? I could. I'll show you another way also. And then we can do rise 1, run 2. Oh, I need a y-intercept. Can I go down 1 and back 2? Is that the same? We talked about that a while ago. Down 1, back 2. Oh, there's my y-intercept right there. Look at my line. If I draw it, is it parallel? So I can write the equation y equals 1/2 x plus 4. Now, sometimes we have a graph and maybe you don't like counting backwards. So we could technically, we have a slope and we have a point. So you can always default to y minus y1 equals mx minus x1. Okay? Do you like that method better? It depends. If you like graphing it, you can, or if you like the formula, you can. So let's go ahead and let's check and see if we did this right. So let's distribute like you told me to do on the other one. Y minus 6 equals, what's half of -4? What's half of 4? 2. And then what do I do with my 6? Add 6, because it's a minus. Tell me about -2 plus 6. +4. Oh, is that what we got a minute ago? Yes. So that I wanted you to see that it doesn't matter. You can either graph it or you can use the formula. So now we're talking about perpendicular. What do we need to remember about the word perpendicular? Okay, opposite sign and flip. Okay, so we need to start with what is the slope in y equals 2x plus 7? Where's the slope? If it's the 2. Can I put 2 over 1? Okay, so let's talk through this. So if my slope is 2 over 1, and we said, okay, that one's going up, we need to make it go down. How do we make it go down? Make it a what? Negative. So we're going to change the sign, and we need to flip it. So now it's not 2 over 1. What is it? 1 over 2. Negative 1 over 2. So I'm going to use this point and this slope. Can we use our y minus y1 now? All right, so y minus, be careful with your signs. What are we going to do? Minus 1 equals negative 1/2 x, be careful, plus 2. Good job, because when we plug that in, the sign changes. So let's distribute. What is half of 2? Negative what? Negative 1. And then what do I do with my minus 1 over here? Oh, what happens when I add 1 to negative 1? Y equals negative 1/2 x. We could put plus 0, or we can leave it like that. So let's look at it on a graph. Do you want to do it on the graph, or do you just want to stick with the formula? The formula? Okay. If we're going to stick with the formula, we still have to use the graph to find the what? The slope. All right. And you know that this slope is going up, so our new slope is going to have to go down. So we know our new slope is negative. So let's count. Rise over run. 1, 2, 3. Make sure you're counting the bubbles. 1, 2, 3, 4. So our original slope is 3 over 4. I need to make it negative, which we already did. And what is it going to be when we flip it? Negative 4 over 3. Now I can use my formula. So let's set up our formula. This is our x1 and our y1. And we've got our new slope right here. So y minus what? Y minus, what's my y1? 3 equals, what's my new slope? My negative 4 over 3. X, what's my x1? Positive 8, because it was a negative, right? A minus minus. So now we can distribute. You might want to use your calculator here. Y minus 3 equals negative 4 over 3x. What is negative 4 over 3 times 8? It's going to be a fraction, and that's okay. Should be negative 32 over 3. Don't freak out about the fraction. You have a calculator that will do that. And then we still need to move that 3 over. How do we move over the 3? We're going to add 3. Guys, again, it's a fraction. Don't stress. You have a calculator. Y equals negative 4 over 3x. Someone in their calculator, negative 32 over 3 plus 3. Negative 23 over 3. That is almost 8 would be our y-intercept. So doing this on our graph like we did the parallel one, we would not be able to get an exact y-intercept. So in that case, the formula is going to be way easier.